Welcome to video 10-4B, the second in the series of videos for section 10-4. You've only got one more to go after this one. We're looking at Explain 2 right now on page 540, and we've already talked about how to prove whether it's a parallelogram or not. In this section we're going to be talking about proving specific conditions about the parallelograms. So here we go. In example 2 we're given QRST here, and we are in part A asked to prove that the diagonals are congruent. Anytime we're talking about congruence with coordinates, we know we're going to be using lengths or distance formula. So remember to skip a letter. If we have QRST, then a diagonal is going to connect Q to S and R to T. Remember, we're going across the figure like so. So we're going to compare the length of SQ to RT. And you can see there with the distance formula calculations that both of them come out to be a nice square root of 65. So if the diagonals are congruent, then we know we've proven that, and they are. Once we know the diagonals are congruent, remember, figures that have diagonals congruent, as long as we know it's a parallelogram, means that it's also a rectangle. So now what we need to prove is, does the rectangle exist? And to do that, we're going to be finding the slope of each of the sides. Remember, slope from the video 10-2, we were talking about getting those opposite reciprocal situations happening. So we need to find a bunch of slopes here. They've already found us the slope of QR, and that is -1/2. And so we're going to start and pick up by filling in the slope of RS. So we're going to go ahead and say 4 minus 0 all over -2 minus 4. And remember, you can subtract these in either order. You could do 0 minus 4 and 4 minus -2 and get the same result. So 4 over 2 does come out to be just 2. So it looks like we do have some consecutive sides there that might be opposite reciprocals. Let's see what else we get. For the slope of ST, we're going to have 1 minus 4 over 4 minus -2, and we're going to get a -3 over 6, or -1/2. Finally, the slope of TQ, or QT, whichever way you want to say it, we're going to go ahead and look at Q and T, and that's my y2 and my y1, so 1 minus -3 all over 4 minus 2 is +4 over +2, or 2. Moving on down the page a little bit, using those same slope outcomes that we just had, slope of QR, or -1/2, times the slope of RS, or 2, does equal -1. Move to the next set. RS's slope, which we know is 2, times the slope of ST, which is now been found to be -1/2. Does that equal -1? Yes, it does. Move on to the next pairing, which is the slope of ST, which we know is -1/2. And +2 is the slope of TQ. We get a -1 there. And then our final fourth consecutive sides pairing, TQ back to QR. TQ is 2. And then the slope of QR is back to -1/2 again. Since we get 4 products of -1, we know that adjacent sides are all perpendicular. And so quadrilateral QRST is a rectangle. So those two pieces, A and B together, determining that the diagonals were congruent and that adjacent sides were perpendicular, means that we have a rectangle. Sometimes in these videos we may need to combine a couple of different formulas together, and you're going to see that as we head towards our assessment at the end of this week. Alright, in the your turns that you're being asked to do this time, we're being asked to prove or disprove each statement about the quadrilateral that's shown in the diagram. That's W, X, Y, Z. And we're being asked to show, is it a rhombus? So remember the characteristics of a rhombus there are that we've got 4 congruent sides, so remember which formula we need to use. And then for question 8, prove that the diagonals are perpendicular. So remember, in the diagonals we skip letters here. Make sure you're connecting the right 2 points at a time as you're doing your slope. All right, we'll see you in the next video.